not the, everything is lining up. Let's see if we can pick up another breadboard. Okay. There we go.
That works.
That one works. Everything is lining up. It's a little bit different, probably a different manufacturer. Let's take a look here on the breadboard. They do the half plus. Okay, that's what it looks like. When we go just half, it works. When it's half plus, does not work. So, let's go back to just half. Make sure it lines up. There we go. And let's get rid of this one. Now, if we take a look at our RGB LED, we see that there's a long leg. Go ahead and get that leg, push it forward, and make like a little step, like that. The reason we're doing that is so we can denote that that's going to be the big long leg. Don't be afraid, you're not going to break anything. Just move it forward and just bend it a little bit. That's going to allow us to know that that is what's going to connect, that's the leg that's going to connect to ground in our board. So I'll go ahead and do that right here. And I'm going to put that right here, directly, and I'm going to open up this just a little bit so that it fits in there. Like this. 1, 2, 3 legs. One connected to ground. There we go. Okay. See if you guys can see that. The big leg is connected to the ground or the blue line all the way. And then the red and the other legs are connected to the lines. Okay? So I'm going to go ahead and pass this to you guys and you try to do the same thing. Okay? This is how it looks from the side. Got it? Perfect. Okay. So basically what we're doing is we're connecting one of the legs, the big leg, to the ground and the other ones there. I cannot do it in the drawing, but that's what we're trying to do. So we go ahead and find the resistor. R1. Here the R1 resistor, we can go ahead and change the resistance and change this to 60 ohms. See what happens. 60 ohms, it changed to the color. See how cool this is? Blue, black, black. So you can change the value right here at the bottom. And I'm going to go ahead and get 2 more resistors. Okay. Here it is. The next one. And one more. Let me take a look and see which of the legs is the one that I used for the RGB. You have, can I see that?
Yeah. You have your bottom one at 21.
Let me borrow first.
And your top one at 18.
Okay, so it's the second leg. Based on this, is my second leg that's going to ground. Okay. Right? Yeah. That's the long leg, right? Okay. So that's correct, the way this is. This leg is the one that's going to ground right here. So what I'm going to do is I'm going to put since I cannot bend the drawing, the leg on the drawing, I'm going to go ahead and put a connector right away from here to ground.
Oh, the longest leg, right?
Huh?
The longest leg.
You're going to make a little knee type like the one. So I'm going to make this black, change the color of this to black, so you know that that connects to ground. You don't have to put this if you already painted this leg and it's going to the blue line. The blue line is the negative line. So this is your leg bended and it's connected right there, but since we cannot bend the drawing, I'm connecting this directly to here. Like that. Okay? So far so good. Let's change the values of these resistors. Make sure we have the correct values. This one is supposed to be 60. We put 60. Pretty cool. Change the color. This one, gonna change to 60 as well.
So how do you know which leg is what color?
On the resistor, it doesn't matter.
On the specs? Or does it matter?
Doesn't matter. You can do this one way or another. That's a great question. The question was, does it matter which side you put the resistor?
Yes.
Either the blue on one side, and black, or the black, blue. It does not matter because resistors don't have a direction. They all have the same value. Basically, a resistor resists the current, the voltage. It helps us do it's a resistor. It resists the current, and it works with the voltage to drop it. That's the purpose of it. So in other words, it's not a perfect conductor. It has a value of how much conductance and resistance it has.
It's like a faucet.
Yeah, like a faucet.
It doesn't matter
Enough
which way the
that you
water is
control
going.
how much the water is going through a pipe. Thank you. That's a
How
great
about on the
analogy.
LED though?
Huh?
Yeah, it's got
On the
color.
LED.
The LED does have a direction. If you take a look at here, I forgot to put the line here. The LED, the one that has the line is the negative, and this side is the positive. I'm going to do it with different colors so you guys can see it a little bit better. This is the positive side of the LED, and the other side is the negative side. And let me see I'll do it with this color. And this is pointing like an arrow going this way. If I put this backwards, it will not work. An LED is actually a diode. A diode controls the flow of current, so it can only go in one direction. If you think of this line as a wall, if you come in here and you get to a wall, you cannot pass through the wall. So if you put this backwards and you're trying to connect something going this way, you will not be able to do it because the way that the diode, the LED is made, the direction of current can only go one way, and it's the direction where it's pointing down. So basically, this is how our current is going from positive to negative. A negative is abbreviated with this little symbol of ground. Big line, small, smaller, which is different than the battery. So you guys don't get confused. The battery is like this: positive, negative. The positive side of the battery, the negative. The ground is big, smaller, like a triangle. So, very good question. The diode, which is the LEDs, I consider a diode, only goes in one direction.
But on the
So a diode is used many times to control the direction. For example, if you have a device and you put the batteries backwards, they usually put a diode there to protect your device from opposite current. If you didn't have a diode, you could blow your device if you connect the batteries backwards. So it blocks the current if you put it backwards going into the device. And that's very highly used in solar panels that are going into inverters and so forth. If you imagine putting the current, the voltage, hundreds of volts backwards into your inverter and other electronics that you need from a solar panel, and you just blow
big one
So you
goes
need
to
a,
the
you have a
negative.
very high value of a diode that protects it. Okay, so we have this so far. Let's go ahead and pick the pins that we're going to use. We're going to do 9, 10, and 11. So put a wire from 9 to there, from 10, somewhere in that line, and then 11. Right. I'm going to zoom in there and see. I'm not sure which one is the red, which one is the green and the blue. I'll just give them colors. Once we light it up, we're going to be able to see which one it is. So I'll go ahead and just change the color here from black to red. This is going to be green. Hopefully we have matched this, and this might be the bluest. Then the other thing we need is to put our power supply here. We need to connect the ground to the ground. Make that black. The 5 volts coming from here.
So John Paul, can we make a correction on here while we're at it, that the red has the different value?
Yeah, right now we're gonna just use the same values from the two. 10 ohms is not that much different. It's not gonna blow them.
Right.
So either we get a 50 or a 60 ohm. It does not matter. Did you guys find the resistors?
No.
You found 50?
I found the close one.
Okay. What values do you have? Do you have the 50 ones? 50 ohms?
That was the, oh, wait a minute.
I don't think so.
No? Well, yeah, have Dad look at that.
Let's take a look.
Because the other ones that we found were like brown, black, black. So they were like 10 ohms.
10 ohms.
I found a brown, black, silver.
Okay. Let's take a look. We don't have to be that close. I think many of the ones. Let's see. Oh, black. It looks like blue,
But
red,
it's
and
gray.
black. Okay, let me take a look and see what I have here. Really quick, let's connect them.
Is this one?
Maybe. Let's check it with an ohm meter. The other way you can check is with an ohm meter.
Go to 70. It's not 60 or 50.
You got 70?
Yeah.
Oh, pretty cool. 70 will work. Let's take a look. Let's double check it. Voltage. That. It's saying 0.
Oh, that's not working.
Meter may be acting up. Okay. Let me see if I have my other meter.
It's green, brown, black, gold.
It's good to have
51, right?
It's green, brown, black,
Is the what?
Black.
Chantal, is this 51, green, blue, and black?
Let me take a look.
Green
This
is
is
4.
460.
Green is
Which one
5,
the one
yeah.
that you said?
If it's green, brown, black, it's 51. I mean, it's correct, but 50, right?
51. Pretty good.
Okay.
Exactly.
Oh, we have some.
This is good.
That's 'cause it's saying 0.
That's 51. Go ahead and grab 3 of those.
Me?
And yeah, and we're gonna pass on to the rest.
I'm gonna grab 2 and then pass it on so somebody else can use them.
Yeah, you can use that. No problem. Try those 2. Okay, so what we're gonna do right here is we're gonna test these other ones and see if we come. That one is not working. We're gonna test it with here. We're gonna see if we can come up with something close to what we need. These are 100. Let's see.
Oh, I think
128. This is huge.
this is not it. It was this one. Oh, Oh yeah, this is the one. Dad, here, can you check this one?
Yeah, I'm gonna check in a second. This is 300, and let me see this. Oh, this is good. This is 70. 70. Go ahead and give that to them so they can use it. To one of them, whoever wants to. Actually, let me get 3 of those real quick. Polly.
This is black, brown, yellow.
Okay. This is about 148. Let me get 3 of those. You need one.
I need 2. I need 3.
Picking these joints.
Oh, I can bet it. Yeah.
Okay, cool.
Yeah, I just slightly bended using the table.
So we're gonna find something that we can use. In this case, let me take a look at this one. Get a little bit close up here.
Move this over. These are nice thick wires. Here.
These are too huge. They're in the 500, 500,000. Let's try this other one right here.
All together. And then
Can you see what is being displayed there? These are about 148 ohms. Oh, that's awesome. Very nice and clear. I'm gonna use this for right now, even though it's not the exact, but I think it'll still work.
This row connected.
So you guys.
Oh, you'll move the light down.
Yeah, I'm gonna give you this 3.
Alright, cool.
Those 3 will work for you.
I think you'll challenge you, so.
Another 3 here. These are 148. They will still work. They're close enough.
140
Yeah.
instead of 50.
Instead of 50, it will still work for our purposes. So what we're gonna do is connect those, and I have something already here connected.
3 more?
Oh yes, right here. Let me double check this.
What's that? Oh, what are you feeling?
Yeah.
Is that?
That's okay. It's so small. It's not gonna come.
But, yeah, choose 8, 9, and
Okay. Yeah, we have these 2 that are within the range that I think it will work. See if you can get some close-up of them connecting all that. Try these 2 for right now.
Yeah, these numbers
Oh,
are
here's
not gonna match. So 10 is gonna be 15.
All right, so you guys hurry up and please build that.
Actually,
We
we
got
can make
about
it
10 more
17.
minutes.
That way we can line this up with
So
it.
we're gonna get this going.
You mean 11 on 7?
So I connected my Arduino Uno, and now I'm gonna connect to pin 6, 7. What are they? 9, 10, and 11.
This is really tall.
I have the green on pin 10,
Hey, how much?
the blue on pin 9, and the red on pin 11. Can you get a close-up of this, please? So people can take a look. Okay, so I got my 3 wires connected and my ground. And let me take a look. My ground in my case is going directly to that pin where the big leg is. Now I'm going to go to the Arduino code. And we literally have 10 minutes to finish this, because I know they're going to start closing soon at the library. But if you open your Arduino IDE, we're going to go to the same program as we did last week, the Blink program, and we're going to modify it. Or we can write a quick one here. Do a little close-up of here so people can see that. So here we have the ground going to the big leg. We have the red going to the other leg through this resistor, going to pin 11. The green, and I have the green wire just to match, is going to pin 10, and the blue to pin 9. So now what we're doing is basically sending the information through all these three wires, the voltages, going through the resistors to light up that LED.
Is there any way you can go back to that diagram you had?
Yeah, what I'll do is I'll put this here, and I'll put the diagram.
You know how to do it, right? You have the jumper.
This is the only part that you need, basically. I'm going to make this bigger.
So it's not work.
That resistor doesn't work.
It does.
We're going to go to examples, basics, blink. This is the blink program that we had last week, and we're going to modify this program. We don't need anything up here. It's just basically comments, so we're going to delete. And right here is the basic part of the program. In this case, if you take a look, we're using pin 13, but we're going to modify it to pin 9. And we're going to add the other pins, 10 and 11, right here. So we have 3 pins, 9, and then we're going to do pin 10 and pin 11 as being outputs. So we have initialized pins 9, 10, and pins 11. Can you put a little bit zoom in into the code of what we're doing? And we have made those outputs. And here we're going to do pin 9 as being high. Pin 10. And there's a little delay here. And here I'm going to go ahead and add another 2.
Still it's not
So
working.
you know these are all different voltages.
Still it's not working.
So basically we're tripling the stuff that we did last week, and we're going to make all of them high so that the 5 pins are being sent out.
No, you can't do that. Because
I'm
High,
gonna take a picture of that so you
and
can see
another
it.
one high.
no, fine. I know how to see it. I know how to do it.
That's it. So right now we're turning all of them on,
What do you mean it doesn't
and it should be a white light when that
There's a
happens.
feeling
So let me go ahead and make sure I'm connected to my board on port 6. I'm using the Arduino
No, you're not
Uno.
connecting it right.
I'm going to go ahead and test out, see if this works. So far the compiling is happening. Can you zoom in please right here? I'm about to light up the LED.
Set
Uh,
code and delay.
Okay, zoom in right here. The compiling is being done. There are no errors. So basically I'm setting pin 9 to an output, pin 10 to an output, and pin mode 11 to an output.
Use this one.
And then with the digital write, I'm turning
No,
those
just
on.
set
So when I go ahead and
It's
load
not in
this,
How
it should
is it
send the
supposed to be?
signals, and that should turn on to
It's not in.
a white light.
There it is, look.
Right now it's uploading. We see the little blinking lights. It has lit up, and that's supposed to be kind of like white,
But it's stepped.
but it's kind of a little bit off. So right now I'm going to turn on pin 9. I'm going to make that a comment. And pin 10, and I'm going to go ahead and resend it, and it should change the color to just one color,
Do like this.
red. So right now, if you take a look,
Pin 11.
Juan Pablo, is this being zoomed in?
It's the red line.
Right now, if you take a look, pin 11 is supposed to be red. And let's take a look. Hey, we matched it. It's perfect. Pin 11 here is being sent out and it's turning red. Now I'm going to go ahead
Wait.
and turn off the red color,
Yes, it is.
which is pin 11,
Correct.
and I'm going to turn on the other color, pin 10, and see what happens. I'm going to load the new program, and now it's green. And we matched it. Pin 10, we turned that on, it's green. Now I'm going to turn off pin 11. I'm sorry, pin 9. I'm going to turn that on. And I'm going to turn off pin 10. And I'm going to send it, and that should turn out to be blue. Beautiful. See how amazing this is? We have 3 LEDs inside that LED. A red, a green, and a blue. And now we can change the hues of them and create almost any color in the rainbow that there is.
So how did you make it big? What did you
Okay, what I did is,
You commented out.
I commented out the red and
Width.
the, let's see, let's go ahead and let me
So
put
The plastic.
the names of it. 11 is red.
select the.
So 11, I'm going to put
Find
turn the red
Okay, this.
No, that's mine.
So
That's
you
mine.
commented
LED.
out 10 and 11.
Yep. And then 10 is green. And then 9 is the blue.
It's like pulse mode, 50% on and off.
Wow, I found it.
One big block off.
So as you can see, we have changed the colors of the RGB LED. Now to make them dim, we have to
No.
write a program
I can't talk
that
right
will
now.
go ahead and change the pulses that are going into there. We don't have enough time to do it this time. We'll do it on our next week
What?
as the starting part of the workshop.
Uh-huh.
Any questions, anybody so far? Yes, Polly?
How
something
does
okay.
how does the LED work? Like, how does it light up?
How does it light up?
I'll
Very
send it to her
simply.
WhatsApp.
Great
I have to
question.
go.
We have 5 volts coming out of the blue wire, going to the resistor, dropping those 5 volts into about 3 volts that this needs, and then being connected back to the ground, which completes the circuit. And that's how it lights up. All
No,
done
I mean like how
through
does
the
that
Arduino microcontroller.
Like how was it made?
What is it made? It's made out of different materials that when they connect to each other, they create that light. We can go into more detail. I know Polly is very interested in chemistry and the materials and all that. That's awesome. Very, very nice.
Gallium arsenide.
All right. So any questions from anyone? We'll go ahead and post this sketch, this program, so you can play with it. Next week,
Put the 2 in it.
bring that up.
That's good.
Next week, we're going to try to do the pulse width modulation and let you guys see how we can control the dimness and so forth.
Question.
Yes, there's a question. Can you show the audience? Go ahead.
Rather not.
No, rather not. Okay, stay with me. Go ahead.
Is the next one at 6:15 or 7?
Is the next one what? Next week? It's going to be, let me take a look.
And it's in Orlando, it's not.
Yeah, the next one's going to be on the 2nd of February, and it's going to be in Orlando, at the Florida Mall. If anybody's interested in having total hands-on, please come. At the beginning, we'll do pulse width modulation, but I want to eventually get into joysticks and controlling motors. This is the same way they control motors as well. Very nice. Polly, think I found the resistor value that we needed.
But it's not that much.
Not that much?
Yeah, it's not.
Okay, go check it with the meter and tell me what it is, okay? Anyways, thank you very much. This has one more question?
No, just curious about checking ours out because we didn't have a laptop to drive the code.
Oh, okay, well bring it here.
Yeah. This one.
We have another one right here and we can check it. Let me go ahead and unplug this. Meanwhile, we're checking it. I want to thank everybody for being here for the broadcast, those that are watching at home. I'll post a link so you can see this video if you missed any part. And you'll be able to hopefully replicate what we've done today. Arduino is an amazing platform that we can use to create awesome things. and to be able to do intelligent things. Eventually we want to do a quad helicopter, an RC car, and slash rover from the ground up. And then later get into more medical field devices like the arms and be able to use servos and stuff like that. We also have a meetup, a workshop on home automation as well. So let me go ahead and send the code right here to you guys. And
What is that date again for the next meeting?
thank you.
Is this on? Is it on? Is it on?
Now it's on. Okay, let me go ahead really quick and take a look and see if we put the right port here. Okay, we have not selected the port, that's why we had a problem there. And now, let me go ahead and check the code works. Now we're sending the code. Are you zooming, can you zoom in right here please, real quick? Beautiful. You guys did an awesome job connecting. It's right there, and we have lit up your LED.
Thank you.
Very good job. Thank you everyone. We're gonna conclude this. Next week, if you want to know all the information, go ahead and zoom in. I'm gonna put it in the web page. Okay. To Arduino Electronics 3D Printing and Entrepreneurship, which should be, you can find our webpage at meetup.com. Thank you. Have a great day.
That's, is this where the video's gonna be, or?
Yes. No, the video will be sent out. Will be sent out to everybody in a link, and I'm gonna post it in this webpage right there. At the Arduino Electronics and 3D Printing.